Alright, hello everybody and welcome to the third machine learning and second regression tutorial video. Where we left off, I was asking whether or not the adjusted close column would be a feature or a label. And the answer is really a feature and possibly none of the above. It could be a label if we hadn't already kind of decided that we were using the high minus low percent or the percent change, for example. So you could use an adjusted close as a label if, say, at the beginning of a day you were trying to predict what the close might be that day. But in this case, with the given features that we've chosen, you really wouldn't even know this value. You wouldn't know the high minus low, and you wouldn't know the percent change until the close had already occurred. So if you trained a classifier to predict this value, that would be an incredibly biased classifier. So just kind of, you have to start thinking of these things. Is this even possible in the real world? Because you can kind of find yourself doing things that seem like a great idea at the time, but then it's actually not even possible to do. So in our case, adjusted close will either be a feature or none of the above, in the sense that actually what we'll do is we'll take like the last 10 values of the adjusted close, and that's a feature. And that's most representative of when we actually go and dig in and write the algorithm ourselves. You would take maybe the last 10 values and try to predict a future value. But anyway, more on that later. So the last tutorial we did features, and now in this tutorial we're going to define a label. So since I just got done telling you that this is not going to be a label, what actually would be the label? Well, it would be at some point in the future the price. Okay, and the only price column we have anymore is adjusted close. But what we want to do is actually get the adjusted close in the future, maybe the next day, maybe the next 5 days, something like that. So we need to bring in some new information basically to get that information out into the future. So let's go ahead and close this out and begin working on that. So first of all, we're not going to print out the head anymore. And first of all, we're going to say forecast underscore column, or col, is just going to be equal to adjusted close. I'll explain why we're going to do that in a second, but basically it's just a variable, and later on you could change this variable to be a different forecast column. So you might not be working with stock prices. There's other things that you can use linear regression on, and of course machine learning, other than stock prices. So in the future, if you're not, you can just you'll be able to use very similar code. You'll obviously change the code leading up to this point, but you would just change the forecast column to be whatever you wanted in the future. And I'll show you why when we get to the code, why that's going to be useful. Now what we're going to say is, just in case there's not like missing data, so df.fill_na. So fill_na is just fill. Na is for not available, or in pandas terms it's going to be actually a nan in most cases, and that's not a number. So now we're going to fill na with a specific value. We're going to do negative 99,999, and we're going to say in place equals true. So with machine learning, you can't work with nan data, so you actually have to replace the nan data with something, or you could get rid of that entire column. But you don't want to get rid of data in machine learning. In the real world, you actually will find that you miss a lot of data. You're lacking maybe one column, but you've got the other columns, and you don't want to sacrifice data if you don't have to. So you can do this, and it'll be treated as an outlier in your data set. And again, this is just one more reason why going through and doing the algorithm by hand will help you understand so much better what kind of effect that is going to have on the algorithm. So you'll be thankful that we go through it, and then basically you'll learn through each algorithm what doing something like that will do. So anyways, that's the choice. That's the best choice in my opinion, rather than getting rid of data. Now we're going to forecast out. This is a regression algorithm. Generally, you use regression to forecast out. You don't have to, but generally that's what you're doing. So I'm going to define a forecast out as the equal to being the int value of math.ceiling, and the ceiling will be 0.1 times the len of the df. So first of all, what are we doing there? Also, we need to import math. But first, what are we doing there? Math.ceil will take anything and get to the ceiling. So let's say the length of the data frame was a number that was going to return a decimal point that was going to be like 0.2, right? Let's say that was going to happen. Math.ceil will round that up to 1. So math.ceil just rounds everything up to the nearest whole. So, and then we're making it an integer value, just so, because I think math.ceil will actually return a float, and we don't really want it to be a float either. But anyway, this will be the number of days out. So basically what we're going to do here is we're going to try to predict out 10% of the data frame. And you'll see that actually when we go out and do this, it's not like you'll just get 1 point 10% out. You can get tomorrow's price and the next day's price and so on. You're just using data that came 10 days ago to predict today. Okay, so feel free to change that, right? Maybe you want 0.01, right? Maybe you want to just predict like tomorrow's price or something. You can play around with that if you want. We're just making stuff up basically as we go. So if you want to change that, by all means change it. So let's go ahead and go to the top and import math before we forget. Okay, so now we need so we've got labels, or I'm sorry, we've got features, right? These are our features, or these are our features, and now we need that label. So now that we have forecast out, we can create that label. So we're going to say df, and then the label column. The label will be the equal of df forecast column. So that's why we used forecast column. That way, if later on you decide to change something, you'll be able to just change this variable rather than all the future variables. So it'll be equal to the df forecast column, and then we're going to do a dot shift minus forecast out. That's why we need it to be an int, because we're basically shifting the columns. So what we've done is we're shifting the columns negatively. So it'll go basically, if you have a column here, it'll get shifted up like the spreadsheet almost. This way, each row, the label column for each row will be the adjusted close price 10 days into the future. Okay, so that's our label. So our features are these attributes of what in our mind may cause the adjusted close price in 10 days to change, or 10%. So actually this will be much greater than 10 days because we didn't even specify a time frame. So we can tinker with this number later. It's really not that important. Regression, you're not going to get rich on just this algorithm, I promise you. But it's actually good. You'll find that it's actually not a bad model of stock price, and as you add more useful features, it can get pretty good. But anyway, so now we have our label column, and let's go ahead and just print df.head again. So this just prints like this first 5 rows of the data frame. Again, if there's anything we're doing with pandas that you're like, what is going on? Ask, and I can point you to a tutorial, because I've done tutorials basically on everything that I'm going to be doing. Okay, so these are each of these columns features, and then we finally have a label column that we've this is time into the future for our data. So now what we're going to go ahead and do is, in fact, let me do a df. Let's do df.tail, and also let's just do a df.dropNA, and then in place equals true, because those were some awful high numbers for 10% out. Interesting. So I guess price has changed that much by that shift. So let's try a smaller shift. Fascinating that would be 10% out. That's a little better. Maybe we will use that 0.01. Let's use that one, because the other ones were just so huge. So let's go back to head and see if that number... So if you're not following, I'm just comparing the forecast price to the adjusted close price. So of course, when the stock price opens, this is actually a significant percent change, right, from 50 to 66. But the stock just came out, and of course, Google does very well in time. So yeah. But anyway, yeah, I think we'll go with 0.01. For now. We'll mess with both whenever we go to predict and stuff. Anyway, That's it for this one. So we've done features, we've got our label, and now we're actually ready to train, test, predict, and actually run this algorithm on some realistic data. So stay tuned for that. If you have questions, comments, concerns, whatever up to this point, feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions. And until next time.